Okay, now this is question 3. It's a problem on projectile motion. So this question ifundeka ngale ndlela le. A hot air balloon moves vertically downwards. You move it downwards, the hot air balloon, at a constant velocity of 1.2 meters per second. When it reaches a height of 22 meters from the ground, a ball is dropped from the balloon. I hope I shy anyone lapha phansi. Now refer to the diagram below. So nasi sketch sethu, it's pretty obvious. So lana into esingayenza mhlambe singathatha the downward direction as positive. Yes, ngathatha the downward direction as positive. Ngoba now it's a projectile motion, you must choose a direction for a problem yakho. So it can be negative. Now assume that the dropping of the ball has no effect on the speed of the hot air balloon. Ignore air friction for the motion of the ball. Okay, good. Now 3.1, it explain the term projectile motion. Well, projectile motion is definer as motion, okay, motion of object under the influence of gravitational force. Motion of the object under the influence of a gravitational force only. Why define that? That's the simple reason behind it. That's the simple definition for a projectile motion. Okay, now 3.2 is the hot air balloon in free fall. Give a reason for the answer. So if free fall, whatever object that is falling, but in this case it's none, it's the hot air balloon, whatever object in question, leyo object leyo, in order ukuthi ibe under a free fall, the only force that's acting on that object must be gravitational force, and the acceleration yaleyo object must be the gravitational acceleration kuphela. But in this question basitshela ukuthi the hot air balloon yethu move at a constant velocity of 1.2 meters per second. So loku chaza ukuthini? Chaza ukuthi i-acceleration yale hot air balloon is what? Is 0. And the acceleration my 0 uzoba ne-constant velocity, and the constant velocity chaza ukuthi leyo object ihamba at a 0 acceleration. So ayikho under i-free fall. Why? Because it moves at a constant velocity and it's not accelerating due to gravity. It's not accelerating due to gravity. So I define a city, I think bale on a board instead. This is 3.2. 3.2 city, the balloon is not in free fall. Why? It's not in free fall. Why? Because it is moving at a constant velocity and not moving not accelerating downward. due to gravitational acceleration. Ne? 3.3. 3.3 bathi calculate the time it takes for the ball to hit the ground after it is dropped. Calculate the time it takes for the ball to hit the ground after it is dropped for 4 marks. We have to calculate the time. No, so asithi now ngasokuqala sikhethe the downward direction as a positive, ne? Ungayithatha as a negative nakhona nawufuna, but into yokuqala kwamele uyenze la kuzofuneka ukuthi ukhiphe ini i-data. So the first value esingayikhipha is that the gravitational acceleration is always acting downwards, so g uzoba positive 9.8 meters per second, and then the initial velocity is equal to positive 1,2 meters per second. Ukhumbule phela the object nabayidropa on that hot air balloon, initial velocity yakhona kuzoba 1.2. Why? Ngoba le object ihamba nale hot air balloon, so initial velocity yakhona komele kube this value, and komele ibe in the direction of the balloon, and the balloon is acting downwards, so that's why siba no positive 1.2 meters per second. And then sibanani the height or the displacement is travel ile bola, which is delta y is equal to what? Positive 22 meters what? Down. Ukhumbule le bola li travel njani? Downward. So izo travel a distance of 22 meters. Angisho? Of 22 meters. Well, into ngimentionile la ungabi confused. Gravitational acceleration nangabe udropa le bola from the balloon, i-gravitational acceleration izoqala yenzeni i-act, but meanwhile lisesengaphakathi kwale balloon ilo kanje i-acceleration for that ball izoba ubani? Izoba u-0, but ngoba sele outside the balloon komele u-g wakhona change abo 9.8. so sifuna ini? U-delta t, ne? Sizofuna u-delta t. Now the question elandelayo ukuthi komele uzibuze ukuthi ngiyosebenzisa which formula. Iphi formula sheet manje? Okay. Nayo. Now my equations of motions wethu, ne? Ama-equations of motions wethu nawo la. Ngifuna ubani? U-t. So ngizofuna ukusebenzisa a formula eno delta t, and ayi-4 ama-formulas wami, so there's only one formula engana t, it's this one. So out of the picture, initial velocity but final velocity anginayo, so this one it's out. Bheka in the final, in the initial ngifuna u-t, final velocity anginayo, so i-out. Na this one i-out ngoba u-t akekho, nala kuno final, and anginayo final, and ngifuna u-delta t, so i-out. So the only formula izosebenza it's this one again, ne? It's this one. So izothi delta y, no, well ngoba sebenza nge-vertical motion, instead ukuthi kube u-x la kwamele kube u-y, ngoba according to a coordinate system x is horizontal, y vertical, so sebenzisa u-y instead la. So v initial delta t plus half g, ne, delta t is equal to, so this value nayo ubani? U-delta y ubani? 22. Sengiya-substitute ke manje. Initial value ubani? 1,2 plus 1,2, delta t unknown plus half, u-g ubani? Plus 9,8 delta t squared, so it's 22 equal to 1,2 delta t plus 4,9 delta t squared. So uyabona senginani? A quadratic equation. So the 22 kwamele ngimlethe ngapha ngishiye u-0 ngapha, so it's gonna be 4,9 t squared plus 1 comma 2 delta t minus 22. So quadratic formula, I'm looking for delta t. So who's our subject of this formula? So minus b plus minus b squared minus 4ac all divided by 2a. All divided by 2a. I think check something. 1,2 divided by 4,9. Well, let's just use the formula. Equal to minus b value wa mubane 1,2 plus minus b 1,2 squared minus 4 a ubane 4,9 c negative 22 all divided by 2 4,9 delta t. So delta t is equal to negative 1,2 plus, starting with plus, squared minus 4 times 4,9 times negative 22 divided by 2, 4,9. Okay, beautiful. So the first value t is equal to 2, or the other value t is equal to, for the negative value lana sithola negative 2,24 seconds la ne. This one axi solution isikhathi sethu komele sihlale si positive, so angeke khona uku-afford ukuba ne negative value la. So delta t wethu bani, it's gonna be 2 seconds. So i-final answer yethu ile for 3.3. Now for the final question, ifunde ngale ndlela le, ithi when the ball lands on the ground, it is in contact with the ground. When the ball lands on the ground, asho bayidrobhile, so komele ilande after 22 meters. Uma land on the ground, it is in contact with the ground for 0.3 seconds, and then it bounces vertically upwards with a speed of 15 meters per second, right? So 90 eyenzekayo la, 90 izokwenzeka ke la. Le bhola bazolidropa from the hot air balloon, nayile balloon lapha phezulu. Komele ibe inkulu, but anyway, okay, asithi na ibhalloon yethu, hot air balloon yethu. Balidropa le bhola lizoyehla, liyehle, angisho liyehle, bese nalifika ku ground lizosmasheka bese liba ngathi liba flat nyana, so bese liba in contact with the surface. Ngoba lifuna ukuchange i-direction, komele librike kancane bese libheka phezulu, liyabuyela back futhi, angisho liyabuyela back, bese ke lizoreacha a maximum height la, ne, a maximum height. And siyazi ukuthi ibhola lethu nangabe lifika ku maximum height, i-velocity komele ube ubani, u-0. But from the statement basitshela ukuthi le bhola then it bounces vertically upwards with a speed of 15 meters per second. Nayiqeda ukuba in contact with the surface, iphinde ya-rebound yaphezulu, fika ithi 0, izophinde ibuyele phasi, ibounce iye phezulu, but the height izoba less than the previous one, ibounce iyehle bese iyabounce ibuyele phezulu up until le bhola lize lifike to a point where lihlala liba still, ne? So i-question yethu ithi 3.5, calculate how high the balloon is from the ground when the ball reaches its maximum height after the first bounce, ne? After the first bounce. So sifuna ukwazi ukuthi ibhalloon yethu izobe seyehle kangakanani, ne? Sifuna ukwazi ukuthi ibhalloon yethu izobe iyehle kangakanani ibhola lethu nangabe selifike la, right? Sifuna ukwazi ukuthi izobe iyehle kangakanani uma ibhola lethu selifike la. So ukhumbule the minute udropha ilo kanje ibhola lakho, ukhumbule le hot air balloon iyenzani, imove downwards at a velocity of 1.2, at a constant velocity of 1.2. So the time ilibhizi liyehla le bhola libounce libuyela phezulu. So hot air balloon yethu yenzani, inandi yehla. So sifuna ukwazi ukuthi le bhola nalifika la i-hot air balloon yethu izoba iyehle kangakanani, or ungayibheka so le question, but the question ithi sifuna ukwazi ukuthi le hot air balloon izobe i-high kangakanani from the ground uma ibhola lethu lifika la. So after some time nyana i-hot air balloon yethu izoba seyihamba la, angisho, izoba seyihamba la uma ibhola lethu selifike la or somewhere la, ne? So in order ukuthi siphendule le question leyo kuzodingeka sithole ini, the total time eyithethwe ilelo kanje ile bhola in order ukuthi ifike la. Siyazi ukuthi from, okay, the time isikhathi esithethwe ilelo ka ile bhola from the time le bhola balidropile all the way up to the ground kuthethe how many seconds, 2 seconds, i-calculate-ile angisho. And then the time it took the ball ukuthi ibe in contact with the ground kuthethe how many seconds, 0.3 seconds. Now kuzodingeka sicalculate lesikhathi lesi just before izo-reacha ini i-maximum height. So sebenzisa lesikhathi lesi esitravele le bhola bese sicalculate le distance or i-displacement eyitravelwe ilelo kanje ile hot air balloon le. Bese afterwards nasiceda ukuthola lelo kanye le distance eyitravel ile hot air balloon, so i-subtracta with this height le izosinikeza the distance between the position ye-hot air balloon lana and the ground. So iphendula kanjalo-ke leyo question. So now kuzofuneka ini i-data ke in order ukuthi sicalculate lesikhathi lesi. Siyazi ukuthi le bhola leli uma lisuka uma liceda ukubounce liya phezulu, so iba nani ne-initial velocity of 15 meters per second, bese nalifika ku-maximum height i-velocity yoba ubani u-0. So vf is equal to 0, v initial is equal to, guess, yes, 15 meters per second, negative 15 meters per second. Usakhumbula sithatha i-direction as downward, sisaqala la, yes, sasebenzisa leyo direction futhi, ne? So g, the gravitational acceleration is gonna be plus 9.8 meters per second per second. Ukhumbule sikhuluma ngebhola not nge-hot air balloon, ne? Sisathatha i-reference yethu ezibhola for now ngoba safuna ini isikhathi, the total time esilapsile while le bhola litravela le. And then sifuna ini u-delta t, right? Formula sheet, iphi formula sheet, formula sheet yabale. Okay, now so sibuyela back to ama-equations of motions wethu again. Sibuyela kuma-equations of motion wethu. So i-distance anginayo, out izosebenzisa only the formula le. Ngifuna isikhathi, ngine-acceleration, ngine-initial, ngine-final, and one unknown. So kuzosebenza the first formula ku-formula sheet yethu. So v final is equal to v initial plus gravitational acceleration times delta, plus gravitational acceleration times delta t. So final velocity is 0, initial velocity is negative 15 plus g, it's 9.8 times delta t. So transpose 15, positive 15 equal to 9.8 delta t. Divide 9.8 both sides. So sithola ukuthi delta t is equal to 1.5 0.53 seconds in 2 decimal places. Answer it really. So senginesikhathi esitravele le bhola from la to la ubani u 1,53 seconds. Lesikhathi from la to la, and the time of contact in the ground, as well as the time from the ground all the way up to the maximum height of the first bounce. So uma ngithatha lesikhathi ngisi-add ngithola the total time that lasped, okay, angazi ngilibiza kahle legama, 2 plus 0,3 plus 1,53 izosinikeza the total time esitravele yilolo kanje ile bhola le. Leso sikhathi sizosithatha sisebenzise ucalculate i-distance etravelwe yilelo kanje ile balloon, meanwhile le bhola belibounce. So sithola ukuthi it's 2 plus 0,3 plus 1,53, it's 3,83 seconds. Voila. So ngizothatha lesikhathi lesi, ne? Ngithatha lesikhathi lesi bese ngicalculate ini the distance itravele le hot air balloon, the time ibhola lethu li travel, ne? So in the case of ilo kanje of i-hot air balloon yethu, meanwhile askip data futhi for the balloon, ne? So initial velocity yakhona kuzoba ubani 1,2 plus meters per second, ihamba ngani ni-constant velocity, angisho? And then well akuna final velocity, angesikhulume ngayo ngoba isa-travela lelo kanje yethu le hot air balloon. So sino G plus 9,8 meters per second, and then sibanani sifuna ubani delta y, which is the distance le distance le, ne? And then sofuna nani futhi, well isikhathi sinaso ile total amount of time esiqeda ukuyicalculate at the bottom lapha na ile this one. Lesikhathi lesi lesikhathi esitravel, the time took from la to la, it's this time le esitravele ile bhola le, ne? So delta t is going to be equal to this. So ngizofuna ubani delta y le distance le. So in order ukuthi ngithole delta y ngizosebenzisa le formula le 80, delta y is equal to initial t plus half g t squared is equal to, wait, uG wethu kwamele abe u0 meters per second. Why kisho njalo? Ukhumbule the hot air balloon itravel at a constant velocity, so uG kwamele abe u0 in this case, ne? So if uG awu0 kuchazani, if uG awu0 in this formula, this whole thing is about 0. So ngizosala na this part, initial velocity ubani 1,2, t ubani 3,83 plus 0 la is equal to 1,2 times 3,83 is equal to 4, let's just say 4,6 ngoba i-answer ngithola it's 4,596. So in 2 decimal places it's 60 la meters. So meanwhile le bhola liyehla leli ceda liyabounce la, hot air balloon yethu i-cover a distance of 4,60, ne? So le distance nyana encane le is 4,60 meters, ne? So nangabe travel from la to la i-distance engaka, and bathi ku-question calculate how high the balloon is from the ground when the ball reaches its first maximum height. So in order ukuthi ngithole the height yale balloon le bhola uma selila kwamele ngisubtract ubani lo 22 meters nalo 4.6, so sothi 22 meters minus 4,6. City height yethu is equal to 22 minus 4,6. 22 minus 4,6 is equal to 17,4 meters above the ground. So yeah, problem yethu iphelela lana today. So I hope we enjoyed this video, and then now we enjoyed this video, just leave a thumbs up. Now a question, leave it in the comment section, and then the video lena in the description of this video ngizo share a link for the question paper la ngithethele problem khona. So yeah, thanks for watching, and bye bye, ngizobona kule video elandelayo. Peace.